We are going to be looking at the quadratic formula and the discriminant. So once again, we always want our equation to be in this form, ax squared plus bx plus c equals 0. If it's not, we need to put it in that way. And then also, if we have one x squared plus 5x plus 6, we know that that is x plus 2 and x plus 3 equals 0. So if we factor that quadratic, that's the factors we get. So that means x is equal to negative 2 and x is equal to negative 3. So it has two solutions, two real roots there. If we would graph that, what that looks like, and we've seen this many times, we've seen that the parabola would cross the x-axis like that at negative 3 and negative 2. So that's what that means when you're finding for solving for x there. You're finding where it crosses the x-axis and how many times it's going to cross the x-axis, and here it's crossing it at 2 times. So sometimes our equations, our quadratic equations, are real nice to graph, or nice to factor, like the one we just did there was pretty easy to factor. So if they're not, we can always use completing the square, which we just learned in the last section, or we can use the quadratic formula, which is minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this formula was actually derived, it comes from the completing the square. So the completing the square and the quadratic formula are very similar, or they are related to each other. So if we take our equation, let's go back to the other one, x squared plus 5x plus 6 equals 0. So we got to find our a, b, and c. So our a equals 1, because there is a 1 there. Our b equals 5. And our c equals 6. So all we do now is substitute these numbers into our equation for wherever a is, b is, and c is. So we have minus 5 plus or minus, and we have to have plus or minus because we have the square root. You can always have two answers with square root. The square root of b squared, so that's 5 squared, minus 4 times a, which is 1, times c, which is 6, all over 2 times a, and we said a is 1. So there we just substitute all the equations, or all the numbers in for our variables. So now we have, and this all equals x. Once again, we're trying to find out where it crosses the x-axis. So it equals negative 5 plus or minus the square root of 5 squared is 25. 4 times 1 times 6 is 24, and 2 times 1 is 2. So, continue to simplify that. We have negative 5 plus or minus the square root of 1. 25 minus 4 is 1, all over 2. And I'm going to go to the next page here. So we had negative 5 plus or minus the square root of 1, all over 2. So that's minus 5 plus or minus square root of 1 is 1, all over 2. Now to separate these a little, the plus and minus, these right here, I'd have minus 5 plus 1 over 2, and minus 5 minus 1 over 2, or negative 5 if you want to say it that way, it doesn't matter. So negative 5 plus 1 is negative 4 over 2, which is negative 2, and negative 5 minus 6, or minus 1 is negative 6 all over 2, and that's negative 3. And if you remember from the very first problem I did on the first slide, we said that x equals negative 2 and negative 3, and that's exactly what we're getting right here, negative 2 and negative 3. So we have two real roots. That means we have two answers, and that means it's going to cross the x-axis at those points, which I already showed you on the previous slide on the graph. Alright, let's try another one here. So we have x squared minus 7x plus 1 equals 0. So it's already in the form I want it, in the standard form, ax squared plus bx plus c equals 0, so it's already in that form. Our a equals 1, because, once again, there's a 1 there. And our b is negative 7, and our c equals 1. So, remember our equation was negative b plus or minus the square root of b squared minus 4ac all over 2a. So I substitute those numbers in. So I have negative 7, because this negative here is part of the equation. Then I also have this negative that goes with the 7. So that's why I have two negatives here. So then I have plus or minus the square root of b squared. B is negative 7, so I have negative 7 squared minus 4 times 1 times 1 all over 2 times a, which is a is 1. So I have negative 7, which is positive 7, plus or minus the square root of negative 7 squared is 49, minus 4 times 1 is 4, all over 2 times 1 is 2. So this all equals x again, so it's x equals, should have put that at the beginning, 7 plus or minus square root of 49 minus 4 is 45, all over 2. The square root of 45 can be simplified down to the square root of 9 times the square root of 5. So that's what the square root of 45 equals. So that means square root of 9 times square root of 5, that's 3. Square root of 9 is 3, square root of 5. So that's what I'm going to substitute in for this square root of 45 here. So I have 7 plus or minus 3 square root of 5 over 2. And that would be my answer. Now you can separate that. That's not just one answer. It's separated. It would look like this. 7 plus 3 square root of 5 over 2. And 7 minus 3 square root of 5 over 2. So there's my two answers. It's two real roots. That means I have two answers, and it would cross the x-axis. My parabola would, my graph, at those 2 points. So whatever those 2 points are, I'm not sure exactly, but that means the graph would cross there, those 2 points. Alright, let's do one more here. So this equation is not in the standard form, so we need to put it in there. So we need to put the negative 3 on the other side. So we need to add 3 to both sides. So then we'd end up with 5m squared plus 7m plus 3 equals 0. So our a equals 5, b equals 7, c equals 3. And we're going to put that into our equation, which is negative b plus or minus square root of b squared minus 4ac all over 2a. So we have negative 7 plus or minus the square root of 7 squared minus 4 times a, which is 5, and c, which is 3, all over 2 times a, and we said our a is 5. So I have negative 7 plus or minus square root of 49 minus 4 times 5 is 20, 20 times 3 is 60, all over 2 times 5 is 10. So I have negative 7. Once again, this all equals x. I keep forgetting to put that. This whole thing equals x. We're trying to find out where it crosses the x-axis. That's the whole point in factoring quadratics, is find out the x-intercepts, where it makes the y equal 0. So I'd have negative 7 plus or minus the square root of 49 minus 60 is the square root of negative 11 over 10. And as you learned in the last section, I have a negative square root. So I would take out a negative 1, which means it's an imaginary number. So it would be negative 7 plus or minus I squared 11 over 10. So that would be my answer then. Now if you want to write these separate, you would have negative 7 plus I squared 11 over 10, and negative 7 minus I imaginary 11 over 10. So once again, I have two real roots there, and since they're imaginary numbers, I will graph this over here. The graph of that, and I'm not sure if this is exactly where it would be, I'm just showing you what it means by having an imaginary number in my answer. It means that my parabola would never ever will cross the x-axis. So it's only going to cross it if I don't have imaginary numbers. It's going to touch it or cross it sometime. But since I have imaginary numbers, my parabola never ever will touch the x-axis. So it looks something like that. And like I said, I don't know if this is the position of the graph. It could be over in the negative side or something like that, but I'm just showing you that it will never ever touch the x-axis. Okay, I already wrote some things on here to save some time. So this discriminant, this comes from part of the quadratic formula. So if you go back to the quadratic formula, this part right here is underneath the square root. So you'll see that underneath the square root sign, the radical sign, and that's called the discriminant. If your discriminant, when you substitute numbers in there and solve it, and your answer is greater than 0, that means your graph will intersect the x-axis twice. If it is less than 0, it does not intersect the x-axis at all. That means there's an imaginary number in there, so it's never going to intersect the x-axis. And if your discriminant is equal to 0, it's only going to touch the graph once, the x-axis, your graph. Okay, once again, I want to save some time, so let's add my equation here. Find my a, b, and c. Use my discriminant here. So I want to find out how many times my graph is going to intersect the x-axis. So I substituted my a, b's, and c's in there, so negative 20 squared is 400. 4 times 4 is 16, times 25 is 400. So my answer is 0, and if you go back to the last slide, if it equals 0, then that it's only going to intersect the x-axis once, so it looks something like this. It'd be tangent to the x-axis right there. Now, once again, I'm not saying that that's where it is. It could be over here or something like that, but I'm just saying that it's going to only intersect the x-axis once, at one point. And on the last one, since we'll only intersect once, we only have one real root, meaning we only have one answer there, so it's only going to cross this x-axis once. All right, here we have 49 minus 4, which is 45. 45 is greater than 0. Since it's greater than 0, then it means it's going to, my parabola will intersect the x-axis twice. Once again, I'm not saying this is where it would intersect at, but since this number is greater than 0, from my description a couple slides back, that means it's going to intersect the x-axis twice. So it has two real roots. So if I would factor this whole thing, like we learned way back at the beginning of this chapter, I'd get two answers, meaning it intersect the x-axis twice there. And our last example here, it's already in standard form. So I got my a, b, and c, substitute in there at 49 minus 5 times 4 times 3 is 60, which gave me negative 11. Since that number is less than 0, then we know that it will have an imaginary number in there, so there are no real roots, which means that it is not going to intersect the x-axis at all. And once again, I'm not saying this is what the graph would be. I'm not saying it's going to be right there. I'm just showing that if your answer is less than 0, that means your parabola would never ever intersect the x-axis. So that was kind of a quick lesson on quadratic formula and discriminant. There's some good examples in the book, plus going through this slide again would be helpful too. So hopefully it will help you, and good luck on your homework.